file that you either made or found on Tinkercad or Thingiverse and bring it into Dremel Cut Studio to slice and turn into a 3D printed object ready for printing. So I've actually made this thing in Tinkercad. You might find an image or find a file on Thingiverse. Either way, if you're in Tinkercad, however, you're going to go to Export and then download as an STL. If you're in Thingiverse, your files will be available for download as an STL, but at some point it needs to be that file format in order for Dremel to read it. If I open up Dremel Slicer, which should actually be pinned out of this taskbar, but it wasn't. This is the software that actually takes the 3D file and turns it into a set of instructions for the machine to actually print it. That's a process called toolpathing. So it says, please load a 3D model, so I'm going to do that. I'm going to just open, and then go to Downloads, and there's the file that I just downloaded from Tinkercad. And there it is. So a couple of things we need to keep in mind. One is the scale. We don't necessarily know how big it's going to be as it gets exported from Tinkercad. So if I go to these options here, I can choose scale, and I can either grab these toggles and make it bigger or smaller, sort of imprecisely, or I can adjust these percentages and give a scale factor if I want to make it twice as big. I just did. But keep in mind that I just uniformly scaled it so everything grows with the same proportion. If I wanted for some reason that the image that I found online wasn't quite to my liking, like maybe I thought this was too tall for what it needed to be, but I wanted to keep everything as is, I can turn off uniform scaling and then just adjust the height direction as needed. And you notice it lays it flat for me. I can also adjust the angle of rotation. So let's say it's an object that might be better served by laying flat so that it actually adheres to the print bed properly. I can grab these toggles and rotate it as needed. If I turn off snap rotation, that gives me much more flexibility. It doesn't just go to these hard stops. You can just go to any whole number angle. And I can also just choose the lay flat option and it'll figure out how to lay it flat. Now, you'll notice it's not looking happy here because of these warning signals, and that tells you that I'm below the build plane. So if I just go to move here and bring it up, it should work out. It doesn't look like it is. Let's try that again. There we go. Not sure what the issue there was. Just play with it till it works. That's what I found to be successful. So if I think this is suitable in terms of the size, and you may have to do some calculations for millimeters to inches if you're not familiar with the metric system, you then want to get ready for the print quality and other settings. So in general, I recommend using medium quality, perhaps even low. High quality is just such a small, high quality resolution that it's really going to take a long time to print. So unless it's something that's really intricate, you're going to be fine with medium quality. Infill. One would think, oh, let me just make it solid, but that's really not going to be necessary. 20% honestly is perfectly fine. If it's really thin, like super thin, like I'm talking just a couple of millimeters off the plane or just fractions of a millimeter, you might go with 100%, but really in general you want to shy away from that. Leaving it hollow introduces some risks, so that might not be a good option either. If you go to custom, you can actually specify what percentage you want, but there's some scary settings here that if you're not sure what you're doing could result in some poor quality prints. So if you stay with the recommended, it kind of simplifies everything for you. I recommend leaving build plate adhesion on. In fact, I recommend making it a raft if possible. If I go to adhesion and choose a raft, it'll give me a better option to really make sure my thing gets stuck to the print plate as much as possible. Going back to the recommended settings though, for support, this thing wouldn't really need support. So you notice if you hover over it, gives you some hints. If you have something with a lot of overhangs or parts that are going to physically be off of this checkerboard plane, like hanging up in space here, like if you had like an action figure, let's say, then the arms would be up here, then generating support's a very wise choice. But in this case, I don't want to because mine's pretty much flat as is. And then I can hit prepare and it'll slice it up for me, turn it into instructions to actually print. And you notice it gives me an estimate in terms of print time. This will take an hour 22. Tells me how much PLA plastic it'll take. It'll take about 6 meters worth of plastic, so you may want to check the filament and make sure it actually has that much ready for printing. And at this point, you would plug in a flash drive. So let me go ahead and do that. And you'll notice the save to file as soon as this is plugged into, well, it should change. It normally changes to save to external drive. In this case, it didn't, of course. Not when I needed to. Let's try that again. Well, in any case, in general, this should automatically change to save to external drive, but we can just do it manually. We can just hit save to file, and then choose our external drive, which is right here, I believe. And you'll notice that it's called the gcode file. If I hit save, the instructions are now actually saved onto the flash drive. So I would take this flash drive and pull it out, plug it into the actual printer itself, and select this file, D3 10-point star. And if I look for that file, I'll be able to hit build, and if everything's ready, it'll print properly.